Okay, yeah. So just to start from the beginning again, we'll be giving a brief overview of um, high performance computing clusters, so specifically Hyak at UW, and then also I'll give after like this general overview, I'll give a like a demonstration on how to um, interface with the high performance computing cluster or HPC. Um, and run code on it. So um, this is gonna be like a little cartoon schematic of how everything's connected. So these computers, these are our own local computers. Like for example, this one could be my computer. You might be on your Mac laptop, and each of these computers have their own like amount of resources, but probably they can be limiting, especially if you haven't invested into a lot of money into your computer. You probably don't have a whole lot of memory and such. So what we ultimately want to do is to be able to tunnel from our local computer into let's say here at UW, their HPC, which is a whole like very like structured and well invested. They've put a lot of money into this whole like server infrastructure that includes many different computers, like uh, I guess you call them computers. Or we'll call or they're also called nodes, like you can see here, and they're essentially like the towers on your computer, your local computer, but there's no screens, because we're going to be interfacing with them via some sort of command line shell. Um, so I'll show you the program that we use to kind of log in or interface with the HPC servers. But when we first do so, we enter into what's called a login node. So this in itself is like a computer, but it's more of a landing computer where you can do kind of basic file transfer or navigation across folders. Um, but it's kind of just that, like you shouldn't be running any like heavy computing codes on it. Um, the main important use of this node is to be able to uh, schedule jobs. Meaning, what do I mean by that? That's when you can generate um, what we call interactive sessions on the more high-powered computing nodes. So basically telling the whole server system, hey, I want to use this amount of resources on the specialized computing nodes. So that's what the rest of this infrastructure is. Um, so all of these like computers are interconnected to each other. Um, so in addition to this login node, there are these specialized compute nodes, and this is where all the heavy lifting is done. And all these computers are connected to this mass storage device, probably just a whole bunch of physical drives that are just organized in an ergonomic fashion. So just speaking a little bit more about these compute nodes. Now these are uh, like the towers that contain all the GPUs, the lots of memory and multiple cores, whereas this one doesn't. And again, just to reiterate, your login node is the when you first tunnel in, and where you enter in like a line of code to request resources from these other nodes. And so these other nodes, um, they there are multiple nodes, right? And different entities can purchase new nodes. So, for example, we a while back, like several years ago, spent money, gave it to the UWIT people to build a new like tower that includes some like amount of memory and CPU cores, and so have other groups. So like here, like the cosmology department, I believe has their own node that they purchased. Also, Adrian Fairhall, who's a PI, um, principal investigator, she has her own node as well. And the importance of these is that um, any person who is registered with Hyak um, is actually able to use as much resources as they want. They can request as much as they want. I mean, given that it's within the limit of the whole summation of these nodes, which is probably a lot. And they can use these resources as they see fit, as long as those resources are available. However, let's say you've run a job and you requested some amount that might span cosmology and Fairhall. But let's say that the Fairhall lab just wanted to, they just submitted a new job that requires all the resources on their node. Well, in that case, because you're not a part of their core users, your job will be kicked off and canceled immediately, meaning all of your unsaved data and computations will be canceled. So that's how this kind of structure works, is that there's a general pool that one can use. And then there's also the you're into, because we're part of the NAPE user group, you can the NAPE users have priority to use their own node. So just for those like people are unfamiliar with how these computers, these towers look, it kind of looks different from what we have on our local computers. It's just that these towers are more ergonomically organized to maximize the amount of space to have like these memory chips as well as like the CPU and GPUs. So we kind of went through this already, where all the nodes share similar, it's the same file system. And then you have the login node where you should not do any heavy processing, or the UWIT will yell at you and give you warnings. And then there's these compute nodes that we basically will have to request resources from, and then once we get them, we can run our jobs. So our NAPE node has 40 cores, a little bit under 196 gigabytes of RAM available. And then upon purchasing this node, we also got 500 gigabytes of like persistent storage space, which I'll talk about in this next slide. So there are three different, I guess, folders within this whole storage system that we can use for file storage. So upon registering your NetID to Hyak system, you got a home / your NetID. So here this would be ZOZC for me, and it consists of 10 gigabytes of storage. This storage is persistent, meaning it won't get wiped as one of the other repositories does. And this is good for your own personal codes, scripts, and smaller programs. So I think in theory you could put Miniconda on this. And then this is already created when your NetID is registered. And And then you have the gscratch script folder, and then it also has your net ID. This one you're gonna have to make yourself. This folder basically has basically unlimited storage space, but the files and the data in your root folder here are deleted every 30 days. So this is good for like raw data or analyzed data. You just have to remember to take the data off regularly so they don't get wiped. And then finally, this is the 500 gigabytes folder that I mentioned in the previous slide. This is also persistent and backed up regularly, but for now, do not use this space unless I tell you to or we've discussed it, because not only is there a file like size limit, there's also file number limit, and they're pretty particular about this. We've reached that file number quota before, and just to manage all that a little bit better, just go through me if you think that you need to use that space. But for the most part, it's going to be used for larger and shared programs. Actually, well, I guess the more general Python environments we might put in there, but for example, we like put in a more heavy duty like light sheet microscopy analysis suite in there. So I've talked about like the general infrastructure and everything. What you might be wondering, what are the tools that we can use to interface with the Hyak nodes and everything. So it's these two programs, PuTTY, which is like a command line shell that allows us to write a command line as well as like command line arguments and lines to be able to interact with the cluster for you to request resources and also run your code. And then WinSCP, at least this is for Windows. I guess for Mac, I'm not exactly sure what you should use, but maybe search like the Mac equivalent. So WinSCP is used for transferring files to and from your local computer to the Hyak servers. So the order will be you use WinSCP to transfer your raw data and your files over, and then you use PuTTY to execute the scripts. So now I'll switch over to the actual programs. So first off, we'll look at WinSCP. Last time I did this, I was running into issues, but I think it was on the server side. Hopefully it's smoother this time. So when you open this up, it's going to look like this, where there's nothing here. So there's really just one field here that's important, and it's its host name. And so what you're going to want to do is type in this clone.hyak.uw.edu, and you should also be able to save it. Yeah, save here. But I already have the preset, so I'll do this, and I also have my username. I guess you could put your password. So I'm gonna log in and then type in my password. Then I'll put authentication. Okay. So basically you have this left window shows you the file structure in your local computer. So I could go to this folder here locally. So where's this? Actually, I want to just go to my documents folder. So that's here already. Thought I had a file. Well, let's just go to GitHub. So yeah, so this is like equivalent to here, right? same files and everything. On this side, this is the Hyak's file server system. Right now, I'm in my home folder. Remember, this is my own personal one with 10 gigabytes of storage. And you can see that I have some scripts and then also have Miniconda here. And then let me navigate to the other one. So gscratch, the gscratch scrubbed. Remember, this is the folder system that gets wiped every so often, 30 days. And you can see here that I have my own one as well, but there's like nothing in here because it's all gotten wiped. So this one's the one that you're gonna want to make your own one with your net ID. And this is where you want to store your data. And then finally, forgot the exact. This is also gscratch. And then here's the NAPE one. NAPE is here. And then you can see that our common has the light sheet microscopy data analysis. I think I have, I don't have, you can put like bookmarks to certain folders. So you might want to do that for your home folder. You can avoid just having to navigate to it. So I'm going to work off my home folder for now. So for example, if I wanted to make a Python file in here, and then we'll just do something very simple. Let's just do print. So we have that file locally, right? And then let's say we want to bring it over to the cluster, file storage, then you want to click upload, and then just press OK. And then you can see it's appeared on the cluster. So now, let's say that that's all you need right now. I guess if you wanted to, you could like upload data to the gscratch, and then in the Python code, it would refer to that specific folder's contents to analyze. But we're just going to work with this for now. At this point, we want to run our files, run our code. So I'll go to PuTTY, which is a separate program. And again, it's going to look similar where at first this might be empty, but you're going to want to, I have a preset already, but you want to just put in that host name again, similar as what you did with WinSCP. Click open, and then type in your net ID. Here, when you type in your password, it's not going to show up like updated, but it's registering it anyway. So just type it in and just press enter. And it's going to get into just blow this up a little bit. This is gonna look. This is what it's gonna look like when you first log in to this login node. See how it says login right here? That's indicating that we are now in this first level of the cluster. So here we can go navigate around to certain folders. If I do ls, then you'll see that I am in this folder here by default. And here's our test folder. I can go to CD, let's see, programs if I wanted. and then get out. Okay, so at this point, don't run any of these files. What we're going to want to do is create an interactive session and request resources on the cluster. So I have these lines of code in here to do so. Okay, so this is just like another static representation of what I just did. Here's some lines of code to use in this shell to do different things like the CD, and then these are specific to running and looking at jobs. So here are the important lines of code, where this one is for running getting an interactive session across the general pool on Hyak, whereas this is for specifically asking for resources on the NAPE node. So I'm going to do this for now, and you can see that there's this srun is the command, and then all these different arguments, where compute is our specific node partition, and then the count is NAPE, and then n tasks per node is how many cores to be allocated. Time is how long you want this session to last before it closes down and cancels everything. Memory is memory, obviously. So I'm going to do this. Pasted it and ran it, and now it's looking for resources, and then now it's allocated the resources. So now see how this is changed to a specific n and then number, not the login. That's showing you that indeed it's now you're in the interactive session. And also what I can do is type in sq-u and then my net ID, and it'll show me the interactive sessions that I have open. If I wanted to, I can kill this interactive session. I could do s-cancel and then this particular job ID. So now that I'm in this node, or not in this node, but this, oh yeah. So now that I'm in this computing node, but we're still working through the same file structure, right? So we've switched to a different computer tower or node, but we're still in the same folder structure. But what I can do now is do Python test cluster. Seems like I already have a test before. So now when I execute the Python code, it runs as I expect. Okay, so that's the basics of using the cluster. You can imagine how you can use this foundation to run your own code and everything. If there's anything else I want to mention here. So here, there's just some more documentation that the Hyak folks have written up to maybe walk you through some other specific aspects of the cluster, and then you can also contact them directly by emailing help@uw.edu, and then in the title you should include Hyak as well as the specific issue summary. Okay, so you can stop there. Do you have any questions about all this?
No, can you send me